All right, we are determining the names and formulas of ionic compounds. The difference between this section and the last section that we did is that this is incorporating binary and ternary ionic compounds. That means it's a mix. You're going to have a metal with a nonmetal, or you're going to have a metal with a group of nonmetals, which would be a polyatomic ion attached. Or there's a polyatomic ion at the beginning, and it's going to end with a single nonmetal, okay? So there may be two different elements, a metal and a nonmetal, or there may be three, a metal with two different nonmetals or two nonmetals with another nonmetal ion attached, depending, okay? So we're going to be using your periodic table and the polyatomic ions that are listed on the bottom left. Also, some of the polyatomic ion tricks using the 3-4-4-3 numbering system on the right-hand side. So I'll point them out when we get there. So let's take a look. Barium sulfate. Sulfate is a polyatomic ion, okay? It has sulfur with oxygen attached. Remember, when it ends in 8, that means you're probably looking at the right-hand side of the 3-4-4-3 numbering system. The formula for sulfate is SO4 -2, okay? So the numbers and the charges are the same, so they cancel, and you get BaSO4. For the next one, silver nitrate. Silver is one of the transition metals that has an assigned charge because it has shading over it. It has a +1 charge that you should have made a note of. And then nitrate is a polyatomic ion containing nitrogen. It's nitrogen with oxygen attached. Remember, there's a circle around nitrogen going over to group 7A, because when oxygen is attached to nitrogen, it follows that numbering system. So nitrate is NO3 -1. The numbers and the charges cancel, and you get AgNO3. Mercury 2 bromide. So mercury 2 would be Hg +2, and then bromide is going to be Br with a -1 charge. You take the numbers in the charges and you cross them, and you get HgBr2. Tin 4 oxalate. Tin is Sn. It has a +4 charge because they gave us a Roman numeral. Oxalate is on the bottom left of your periodic table with the rest of the polyatomic ions. Its formula is C2O4 -2. Okay? So the numbers in the charges are going to cross, and you get Sn2, but now you have to put parentheses around the polyatomic ion, because anytime you take a charge and then you cross it over a polyatomic ion and end up writing it as a subscript on the polyatomic ion, you've got to put that polyatomic ion in parentheses, okay, because it's a group. And when the charges have numbers that are divisible by the same thing, like 2, 3, 4, then you would simplify them. This doesn't happen that often. It happens, I don't know, 10% of the time. So here, you've got a 2 and a 4, which are both divisible by 2. So you have to simplify it, okay? So this would end up being Sn parentheses C2O4 parentheses 2. If you didn't simplify it, it would be wrong. E, aluminum dichromate. Aluminum is Al +3. Remember, it has an assigned charge because it has shading over it. Dichromate is on the bottom left of your periodic table. Its chemical formula is Cr2O7, and its charge is a -2. You're going to cross the numbers and the charges. You're going to end up with Al2 parentheses Cr2O7 parentheses 3. Potassium fluoride, K+1, F -1. The numbers and the charges cancel. You get Kf. Okay? So do you see how this was a mix of binary ionic compounds and ternary ionic compounds? All right, let's take a look at number 2. For number 2, we're going to write the names of chemical formulas, and these are binary and ternary ionic compounds. So it's a mix. So you're going to see some polyatomic ions in here. What I'm going to do is I'm going to go ahead and underline the compounds that have a transition metal that requires us to calculate the charge. Because remember, I told you in a previous lesson that if you have a transition metal that requires Roman numerals, then you have to calculate that charge. So we're going to wait on those. Let's do the rest. Zn is zinc. When you have parentheses, look inside the parentheses and name what is inside the parentheses only. This is hydroxide. Hydroxide is listed on the bottom left of your periodic table as one of the polyatomic ions. We're going to skip B and C. We're going to go to D. Na is sodium. Now, what's attached to sodium may not look familiar. This is actually acetate, which is also on the bottom left of your periodic table. Acetate can be written a couple of different ways. Sometimes you'll see it as CH3COO. Sometimes you'll see it as C2H3O2, and that's because you have 2 carbon, here are your 3 hydrogen, and here are your 2 oxygen. So just be familiar with that, okay? So this is sodium acetate. For letter E, Mg is magnesium. I is iodine, but we change the ending to ide. Okay, remember, when there's no oxygen with the when there's no oxygen with the nonmetal on the right-hand side, that means it's not a polyatomic ion, it ends in ide. If oxygen had been attached to iodine, then we would end it in ate or ite. Here, we have to calculate the charge on the iron. So let's go back to B, C, and F. Remember, you start with the nonmetal. I have 1 oxygen. The charge on oxygen is a -2. That's a -2 overall on the anion side. That means you want a cation overall charge of +2 to counter it. You have 1 tin. 1 times what will give you +2? Well, +2. So this is tin, Roman numeral 2, because of this charge that we determined on tin. And then you end the oxygen in ide. So that's oxide. When you have a polyatomic ion in parentheses, you have to put a bracket around what's in the parentheses. You have 2 of these. The overall charge on ClO is -1. This is a -2 overall. You want a +2 overall in the copper. I have 1 copper. 1 times what charge would give me this 2? A 2. So this is copper. Roman numeral 2 because of this charge that we just determined on the copper. And you name what is inside the parentheses only. This is hypochlorite. You're looking at that 3443 numbering system on the right-hand side of the periodic table that I taught you. Letter F. Cr2O7 is a polyatomic ion listed on the bottom left of your periodic table. When you don't have parentheses around a polyatomic ion, you only have 1. So that means here I have 1 of them. The charge on dichromate is a -2. Okay, so this is a -2 overall. It's not -14. Common rookie mistake. If this is a -2, I have a +2 on the other side. I have 1 iron. What would the charge be? It would be 2. So this is iron. Roman numeral 2, because of that charge that we just calculated, and Cr2O7 is dichromate.